The internet has opened rapid, seamless commerce across the globe. Today, it's possible to introduce new products and services at incredible speed and make them available worldwide almost instantaneously. Billions of dollars of transactions are performed across the internet every day. This is only possible because connections across the internet are trusted to be secure. And this trust is provided by TLS. TLS is a cryptographic security protocol that provides authentication and confidentiality. When a person or machine connects to an organization across the internet, they want to know that the sensitive data they're sending is going to the right organization. In addition, they want to make sure that somebody in the middle can't see that data. Organizations provide this level of assurance to their customers by leveraging TLS. They start by deploying unique cryptographic keys called TLS certificates on each of their systems so that those systems can be reliably and uniquely identified across the internet. In this way, anybody connecting to those systems knows that they're sending their data to the right place. In addition, those TLS certificates enable the establishment of secure connections so that anybody in the middle can't eavesdrop on those communications. TLS has provided the trust needed to achieve these unprecedented levels of commerce across the internet. But the role of TLS in securing commerce and communications doesn't stop there. That's because the data being sent to or from organizations doesn't reside at the edge of their networks, but instead deep inside their networks, and each transaction must traverse multiple layers of systems to reach the data where it's stored. With this level of sensitive data traversing their networks, organizations have had to find ways of securing the data against compromise. They've done this by leveraging TLS. They've deployed these unique cryptographic keys, these TLS certificates, across their organization on each system so that the data is secured end to end. As you can see, TLS plays a fundamental role in the security of communications inside and outside of organizations. But with the significant security that TLS provides also come new risks. Each TLS certificate includes an expiration date so that it's changed regularly, just like all of your passwords change regularly. However, if the certificate isn't changed before its expiration date, the application that depends on that certificate can have a major outage. Nearly every enterprise has experienced one or more significant application outages due to certificates that expire before they're changed. Attackers rarely get to the data that they're seeking on the first system that they compromise. Consequently, they need to move from one system to the next within an organization. And with TLS, they can now set up a TLS secured connection from one system to another, and then start performing their vulnerability scanning and then compromise the next system. In this way, they can move from one system to the other undetected, pivoting throughout an environment and getting to the data that they're seeking. And then they can leverage these same TLS connections to exfiltrate the data back out of your organization. The broad numbers of TLS certificates that are being deployed across organizational networks all rely on cryptographic algorithms and libraries to function. If a vulnerability is found in one of those algorithms, or a bug is found in a cryptographic library that's leveraged to implement that algorithm, it's necessary to change large numbers of certificates quickly. Many organizations don't have this ability. They lack what's called crypto agility. Consequently, if an algorithm is found to be weak, they don't have the ability to quickly change to a stronger algorithm. Finally, if an attacker is able to steal a cryptographic key or get a fraudulent certificate, they may be able to impersonate an organization's servers so that customers thinking they're connecting up to the organization are actually connecting up to an attacker and may provide passwords or other information that the attacker can use to get to the data that they would like to get. As the use of TLS has spread across organizations, these risks have only increased. However, it's been challenging for organizations to address these risks because TLS is not a centralized technology. Instead, the management of TLS is spread across each of the different groups responsible for servers and systems in an organization. In many cases, this can spread across different geographies. Central security teams struggle to make sure that certificates are being properly managed by each of these disparate groups. The result is organizations have experienced significant application outages and lost visibility into the malicious activity of attackers within their networks. Because so many organizations have struggled to manage TLS certificates across their enterprise environments, NIST, the National Institute of Standards and Technology, has developed guidelines to help in better managing this critical security technology. This includes guidance on how to establish a formal program that includes policies that explain what should be done to mitigate the operational and security risks related to TLS certificates. It also recommends clear responsibilities so that every party knows their role in complying with those policies. It also provides security teams guidance on how to establish a central certificate service to support the effective management of TLS certificates across the enterprise. In the guidance, NIST makes it clear that because TLS certificates are spread across so many organizational boundaries, that it is critical to have executive engagement. Executives must play both a leadership and oversight role. To help executives in this role, NIST provides specific recommendations for establishing an action plan and for milestones that executives should seek to have completed in order to make sure that an effective program is put into place. NIST has published this guidance in 2 separate volumes. One volume is focused at executives to provide them a high-level overview so that they understand the problem that needs to be addressed and how to guide their teams to effectively put a TLS certificate management program into place. Volume B provides detailed guidance for security directors, managers, and architects in establishing and creating that formal program. This guidance has been published for public review and comment, but organizations can start benefiting from this guidance immediately by putting it into action. As you put this guidance into action, if you find that there are areas that aren't clear or are incomplete, NIST requests that you provide feedback to them on their website so that they can revise the guidance and publish it for the benefit of the entire industry. Thank you very much.